It's interesting that you mentioned homomorphic encryption because as recently as January, there was a prominent Brazilian financial institution which had been working with IBM Research to apply a technique called homomorphic encryption to banking data. The pilot that they did showed that it was actually possible to apply machine learning algorithms to encrypted data without decrypting it, creating a new level of privacy that could be applied possibly to other industries. We see that machine learning is already often used in banking and finance to predict scenarios like transaction fraud or investment outcomes. Typically, though, it also involves vast storage of data, most of which is highly sensitive, but must be decrypted before processing, exposing the data to exfiltration and leaks. What can you say about the strengths and the weaknesses of homomorphic encryption, specifically when it comes to banking and for other financial institutions?
So it's actually machine learning is just one of the examples that are relevant applications for homomorphic encryption use case. It's already used today in also financial organizations and in enterprise blockchain implementations in the world. The thing with the homomorphic encryption, it's highly resource intensive algorithms. So running them on the regular servers, regular PC servers, is extremely slow today. And it's a huge pain for any organization, any company that uses this perfect security. The other problem is, like, let's say the company wants to run the algorithm inside the secure environment and not on the regular PC servers, which nullify the security itself and the encryption of the encryption and decryption. Current appliances like hardware security modules, HSMs, hardware servers, which provide secure environment for doing cryptographic algorithms, they are built for standard requirements and standard algorithms that were invented in 20 years ago, 15 years ago, and they're completely unsuited for the novel zero-knowledge algorithms, which are very different from what we have existing today for key protection only. And so the entire infrastructure that provides security to the bank or to the financial company or to the cloud is hardware based on mature old algorithms and is not upgradable to the newer homomorphic encryption and zero-knowledge algorithms. And it's a huge challenge for companies that how to keep using this homomorphic encryption and while making it fast, just like the existing algorithms, and also easy to use and transparent to the clients. For example, the banks doing the transactions on the network.
Which industries would you say are best suited to adopt homomorphic encryption other than banking or financial institutions? That interests me.
Essentially, everyone who wants to create privacy and also trust when operating on a network with many players, many clients on the same network. It can be a public cloud installation. It can be a financial transaction network. It can be a supply chain management network with a large amount of different suppliers and companies all over the world. So when you want to exchange information, very sensitive information, over the network, over the public network, and keep it private and secure only between the participants that needs to see this information. This is the case for the homomorphic encryption. And for example, even in government, while giving access to external researchers, for example, to the public datum, with the sensitive private information for the population. So today the access can be just the researcher gets the whole database and they tell them, okay, keep it private, don't publish, and then it gets published anyway and leaked by hackers. It happened here in Israel many times in the past. So it's a big problem on the privacy standpoint. So with this novel homomorphic encryption, zero knowledge algorithms, the government can give researcher access and provide him with functions that run on the encrypted database. So even if it leaks, then nothing is exposed. The hackers cannot do anything with it. So this is the excellent benefit of the zero knowledge algorithms for anyone that needs to share the data with external players and external clients.